In this tutorial we will look at the pupil analysis, and I will look at the pupillary light reflex, the PLR, but you can use the same tools to do pupil dilation analysis. I will start where I stopped the second tutorial. I've got 3 subjects with data files from Tobii ProLab. I will read the files and interpolate the gaps, and then we are ready to do something. Next step is to choose which stimuli we want to work with. We do that by adding the plugin events modification. If we enter eye tracking here, we can scan the event names to get a list of all the events in the data file. And we can remove those who are not interesting right now. And in this case, we're only interested in the ones that has a pupillary light reflex in there. And we only want the ones with start. So we've showed 3 different videos, 2 times each. And in this video, which is mainly a black screen, after 1333 milliseconds, there is a white flash in this video, and after 1666 milliseconds, there's a white flash in this one, and after 2 seconds in this one. And by changing the offset, we can say at what time the event marker should start. So if we offset this with 1.333 like this, and this 1.666, and this 222. We've shifted the event time to so that the white flash is at time 0. And now it doesn't matter if what we call these different movies. So we add another column, and let's call it PLR, pupillary light reflex, like this. Now this plugin didn't end up at the end of the list, so we can use the shortcut Ctrl-J or use this menu item to move it down. Do selected work, and it seems like nothing happens, but it changes the name. The next step is to make sure that we don't have any artifacts in the data. So we do that by adding the plugin events reject. Specify eye tracking, and we can look at the different events that we can look at. At the very end, we have our PLR event. You can see that all of the subjects have 6 trials. Now, remember that the white flash starts at 0.0, so we want to start maybe 1 second earlier and stop after 5 seconds. Then we can plot this by having time on the x-axis and the pupil on the y-axis. Now if I click on one of these squares, I will get a plot of the pupil over time. So we can see that at time 0 there is we don't see the flash, but there's a flash. And after some time, the reaction time of the pupil constricts. And I use the arrow keys to move between these different trials, and we can see that data look really good. There's not a lot of missing data. Well, this one looks a bit crappy. This has to go, and I can either do that by pressing the spacebar to remove it, or we can discard trials with a lot of missing data. So if we use this box and say that we need at least 90% of the data, you can see that 4 trials in this participant will be rejected. If we take only 75%, only 2 trials are gone. Let's keep strict here. I will save this setting. And run it. We can now see that it rejected 4 trials out of 6 for the 3rd participant. The next step is to actually get the event-related data. So to get the actual data from these subjects. To do that, there is a plugin called Core Event-Related Data Extraction. It looks like this. And look at the eye tracking field for the pupil. The event was called PLR. We started looking at -1 second to 5 seconds. And this plugin will actually resample the data. So you can set this to whatever you want. I think 120 is fine in the case of pupil. Let's not interpolate the gaps or the trend or set a score. Just keep it as close to what actually happened as possible. And then you can, for each trial, subtract the data from a baseline, or you compensate for the pupil size right before the flash. So we can set the baseline 500 milliseconds before the flash to right at the flash. The analysis interval is the time span in the signal that you're interested in. So you're probably not interested in the whole curve, but maybe after some reaction time. So let's say that we have an analysis interval between 1 and 2 seconds. And we'll take out the mean pupil size in this interval. Or we can take the mean amplitude. Actually, it's perhaps more interesting to look at the interval from the time of the flash to 2 seconds after. Then we can get the mean amplitude, sort of the size of the pupillary light reflex. If you want, you can specify if you want to exclude trials because of missing data or so in here, but we can just keep it as it is. And then we want to plot this. If we keep everything, I will show you what it looks like. And what we get is a window with the data, different trials. And we also get these plots with the data from the different participants. So this analysis will output the mean amplitude within the analysis windows, which we set to 0 to 2. And you can then put this into your statistical analysis. More often you're not interested in looking at individuals like this. So if you want to make a plot for publication or so, you might want to choose another plot type. And we can have groups as figures. We can then plot the mean and the individuals and the standard error like this. And you will get a graph that looks like that. So, of course, if you're interested in another time interval, if you're looking at the pupil dilation, you might want to delay the analysis window to between 1 and 2 seconds, for example. And then you will go into the settings, change this 1 to 2 seconds, and maybe you're interested in the mean amplitude in this time window. When we plot that, you can see that the analysis window has changed, and the numbers that you get in this output, which you can, if you want to, put into Excel or another spreadsheet program. And that's how you can extract time event-related data based on the timestamps. That's it for this tutorial.